Okay, let's try this first trigonometry problem here. They say it's given that the tangent of 50 degrees equals k. Well, tangent's opposite over adjacent, and it's what you do. You can make a little triangle. Instead of opposite over adjacent being k, you go k over 1, and you make yourself a little triangle. Opposite over adjacent, you put in 50 degrees. Then by Pythagoras, you've got the hypotenuse, the square root of these two things squared. 1 squared plus k squared. Well, there's a picture. Now we can get everything we need out of it. Well, not everything, but we can get the cosine of 40 degrees because there's 40 degrees up there. If that's 50, there's 90, that's 40. The cosine must be k over root k squared plus 1. There's the cosine of 40 degrees. We're looking at it. It's the same as the sine of 50 degrees. Okay, now this next one. Look at this 2 sine cos. Oh, that's just an identity. That's just the sine of 50 degrees on the top. So let's try that question there. That's just the sine of 2 times 25, the sine of 50 degrees. Now on the bottom, it's not so nice like this. If we factor out -2, we have 1 minus 2 sine squared of an angle. And our formula sheet tells us that 1 minus 2 sine squared of an angle is really the cosine of double the angle, the cosine of 2 times 20, the cos of 50 degrees. Well, that's pretty nice. And see, we got the little -2 out front. And sine over cosine, hey, that's the tangent of 50 degrees. And what's the tangent of 50 degrees? They told us it was equal to k. So this whole thing must just be minus 1/2 k. What about the sine of 50 degrees? Sine of 10 degrees? Well, we know the sine of 10 degrees is the cos of 80 degrees. And 2 times 40, the cos of a double angle. The cos of 2 times 40 degrees is the 2 cos squared of half of 80, which is 40 degrees minus 1. That's just an identity from our sheet. But the cos of 40 degrees, we've done that, so we can just substitute it in there. And it's looking a little bit messy, but let's just work it out a bit. If we square this square root, it becomes k squared plus 1 on the outside. K squared on the top, we've got 2k squared over k squared plus 1. Now we're minusing 1. That's the same as k squared plus 1 over k squared plus 1, but we're minusing it. And 2k squared minus k squared is just k squared. And we've got a minus 1 on top. Well, that looks a little nice. K squared minus 1 over k squared plus 1. I think that's what it reduces to. And there you go.